myself Dr. Bharti Patil, working as an assistant professor physics in Maharaja Jivajirao Shinde College, Srigunda, Ahmednagar. We have started our syllabus related to TYBSc solid state physics, and we have started our chapter number 2, that is X-ray diffraction and other characterization techniques. During our last lecture, we have solved few of the examples based on this chapter, and in today's lecture, we will try to cover few more examples based on it. So let's read first example, that is X-ray of wavelength of 1.54 angstrom are used to calculate the spacing of 200 planes in aluminium. The Bragg angle for first order reflection is given as 22.4 angstrom. What is the size of unit cell of the aluminium crystal? Aluminium crystal is given, and they have asked us to find out the size of unit cell. It means that we have to find out the volume of unit cell. So we have to find out volume of unit cell. We know that volume V is equal to A cube. What is A? A is nothing but lattice parameter, where A is equal to lattice parameter. It means that in order to find out the value, we have to find out the value of A first. And how to find out value of A? So let's write given. What is given here? So in given, they have given us the wavelength of X-ray use. It is given as 1.54 angstrom. Then they have also provided the reflection from HKL plane is given as 200. It means that H value is 2, K value is 0, and L value is 0. This information is given. Then Bragg angle for first order reflection is given as 22.4 angstrom. First order means n is equal to 1, and then Bragg's angle means theta is given as 22.4 degree. So this much information is given to us. Now, as we know that we have to find out the value of volume of unit cell, and before that V is equal to A cube. We have to find out the value of A. But in order to calculate the value of A, this information is given. But this information is related to Bragg's law, that is 2d sine theta is equal to n lambda. But here there is no any presence of A. So how to find A? We know that there is one more formula which is in first chapter, and it is gives us relation between interplanar distance and lattice parameter A, and there we have to use these HKL planes. It means that from this information one cannot get the value of A directly, but in order to calculate the value of A, you have to use this formula first. And from this formula, you have to use this formula. But suppose I start to use this formula, then I have to calculate A. This information is known to me. But what about D? D is also not given. So I have to calculate D first. So we have to start solving our example by calculating the value of D first. So let's try to find out the value of D first by using Bragg's law. What is Bragg's law? Bragg's law is given as 2d sine theta is equal to n lambda. So we have to calculate the value of D. D is equal to n lambda upon 2 sine theta. But for first order, for first order, n value is equal to 1. So substitute n as 1 into lambda. Lambda is given as 1.54 angstrom divided by 2 into sine theta. Theta 1 is given as 22.4 degree. So we have to calculate the value of D by substituting all these values, and D comes out as, by solving this value, one can find out the value of D. It comes out as 2.02 angstrom. What is the value of D? D is equal to 2.02 angstrom. Now I can use this value of D here. Now HKL planes are known to me and I can calculate the value of A here. So now I have to use this formula. I will shift this value here. D is equal to 2.02 angstrom. Now we know that D is equal to A upon square root of h square plus k square plus L square, and we have to calculate the value of A. Hence A is equal to D into h square plus k square plus L square. So A is equal to value of D just now we have calculated as 2.02 angstrom into bracket into square root of h value. H value is 2, means 2 is 2 square, plus k value is 0, 0 square, plus L value is 0, 0 square. Therefore 2.02 into square root of 2 square is 4, and 0 square is equal to, now find out the square root of 4. We know that its value is 2, and we have found out 2 2s are 4, 0. 4.04 angstrom is the value of A. So what is the value of A? Value of A is 4.04 angstrom, and we have calculated value of A by substituting value of D in the formula. D is equal to A upon square root of h square plus k square plus L square. Now we have to find out the size of unit cell. So size of unit cell, that is volume, is equal to A cube. That is volume is equal to A cube. So take V is equal to A cube, means 4.04, and we know that we are not expressing volume in terms of angstrom unit. So we will convert this angstrom unit either in centimeter or meter. So we know that 1 angstrom is equal to 10 raised to minus 10 meter. So we will substitute the value of this angstrom in meter. So 4.04 into 10 raised to minus 10 meter cube we have to find out. So 4.04 gives us 65.94 square. Cube of 4.04 comes out as 65.94 into cube of 10 raised to minus 10 is 10 raised to minus 30, and meter cube. It is in meter cube. This is the volume or size of given unit cell. So size of given unit cell is found as 65.94 into 10 raised to minus 13 meter cube. Here only one change we have made, that is we have converted the value of A in angstrom unit into meter and found out the volume in meter cube. Let's see next example. Example number 4. Calculate the glancing angle for a cubic 100 crystal of rock salt. A is equal to 2.814 angstrom, corresponding to second order diffraction maximum for X-rays of wavelength 0.710 angstrom. Calculate the glancing angle. We have to calculate theta, that is glancing angle, is equal to how much? For a cubic crystal plane is given. This is crystal plane. Plane is given means HKL value is provided to us for 100, that is it will give us information related to H is equal to 1, K is equal to 0 and L is equal to 0 of the rock salt, and A is given. A is nothing but lattice parameter. 2.814 angstrom is the value of lattice parameter corresponding to second order diffraction. Second order diffraction means order of the spectrum is the second order. N is equal to 2. Second order diffraction maximum for X-rays of wavelength, and wavelength of X-ray is given as 0.71 angstrom, and we have to find out the glancing angle, that is theta. We know that there is one formula in which this theta lies, that is Bragg's law. From Bragg's law we know that 2d sine theta is equal to n lambda. We have to calculate the value of theta. It means that one should know the value of n, value of lambda and value of d. But here n is given as 2, lambda is given as 0.710 angstrom. But what about d? D is not given here. So initially we have to calculate the value of d. How to calculate the value of d? In order to calculate the value of d, so in order to solve this example, one cannot start the solving example by using Bragg's law first, but we have to calculate the value of d first. We know that d is equal to a upon square root of h square plus k square plus l square. Now substitute the value of a and HKL. Value of A is given as 2.814 divided by square root of h square means 1 square. 1 square plus 0 square plus 0 square. So this value comes out as 2.184 divided by square root of 1. That is, this value is nothing but 2.814 angstrom. This is the value of d, that is interplanar distance d. So we have calculated the value of d as 2.814 angstrom, and now we have to calculate the value of theta by substituting value of d in Bragg's law. What is Bragg's law? 2d sine theta is equal to n lambda, and hence sine theta is equal to n lambda upon 2d, but n for n is equal to 2, hence sine theta is equal to 2 into lambda is given as 0.71 divided by 2 into d. D we have calculated as 2.814. So this gives us value of sine theta, and this value of sine theta comes out as 0.2523. And how to calculate the value of theta? Theta is equal to sine inverse of 0.2523, and thus we have obtained the value of theta as 14 degree. If we find out the value of sine inverse of this, then it gives us the value of theta, that is glancing angle. Theta is equal to 14 degree. Thus we have initially started our example by substituting the value of A and HKL in the formula d is equal to a upon square root of h square plus k square plus l square. We have obtained the value of d. Then by using Bragg's law, we have substituted the value of n, lambda and d, and we have find out the sin theta value, and from that sin theta value we have calculated theta by taking sin inverse of this 0.2523. It gives us theta value as 14 degree. That is, the glancing angle for a cubic crystal is found as 14 degree. Thank you.